Welcome to the Cal Corporation's series of videos about software engineering. The topic of this video is the ordering in which C++ constructors are done. Before proceeding, make sure that you have already watched these other videos first. We've already seen that when you instantiate an object, its class's constructor function gets called to initialize that object's newly allocated memory. Because an object might have many parts, constructing it might involve multiple constructor functions. Let's list the order in which those constructors would get called. The class hierarchy might contain an ancestor which is a virtual base class. If so, that virtual base class's constructor gets called first before all other constructors. If there are multiple such virtual base classes, their constructors are done in a normal depth-first order. Next, base class constructors are called. Of course, this is a recursive thing. Constructing a base class will recursively cause construction of the base. If there are multiple base classes, then their constructors are called in the order they are listed here in our class definition. We also need to specify the parameter values passed to these base class constructors. We specify that in the same place where we would initialize data members. Remember, that's after the colon symbol as we're programming our implementation of the derived class constructor. It often makes sense to delegate a value from a derived class constructor parameter up to a base class constructor parameter. Beware that it does not make any difference in what order the programmer types this information. Next are the constructors for any data members whose type is some kind of object. These composed objects are constructed in the same order that they are listed in the class definition, not the order in which the programmer typed their initialization. If we skip the initialization of some data member that's a composed object, then its default constructor gets used. Lastly, the actual implementation of the derived class constructor finally gets performed. Any constructor can call that class's own member functions, both normal ones and virtual ones, but those calls will not behave polymorphically. Think of it this way. While a base is being constructed, it has not yet polymorphically become a derived object. This rule exists for destructors also, by the way. We've just now shown that we construct composition data members after we construct base classes. Because of that ordering, a composed data member may not be passed as a parameter to a base class constructor function, because you can't pass something that doesn't exist yet. If you need to do something like that kind of passing, there is a programming hack that would make it work. Move the composed object into a new dummy base class. As the programmer, you are able to control that relative ordering so that dummy base class gets constructed before the real base class. By the way, Boost provides a generic implementation of this hack.